Hi. Okay, so let's see. Gotta work this thing. Is this presenting?
Are you're sharing? Are you sharing right now?
Am I sharing? Let me make sure I'm sharing. How do I get to Zoom? Where is the actual Zoom presentation? They're just from the introduction from last year or from last week, Docker. So I just stole these things. But basically, this represents the 4 parts of the infrastructure at HackOregon. With the data repository, that's basically the raw data as we receive it and then stored in databases. And we build APIs to serve it up and then a web front end. So I'm going to be talking mostly about the database part. I'm going to mention a little bit about the getting it into the database and also getting it out of the database, but not too much on either of those things. Here's the Postgres logo, so if you see that, you know you're in the right spot. Some of the basic things that we're going to cover today are the features of Postgres. We're going to talk about CRUD, creating, reading, updating, and deleting data, and how to improve performance, some other tools, some considerations for security, working with PostGIS a little bit, and then focusing on how we use Postgres at HackOregon. Is there anything else that people are thinking of that might be in here yet? No. If you have any questions, just stop me. One thing first thing I wondered about Postgres was why is it called Postgres sometimes and PostGresQL some other times? And it's Postgres because it's post-ingress, which was an earlier database project. And both the project and the product are actually named PostGresQL. But I'm going to call it Postgres most of the time because I forget the SQL. And then also, I don't know if some people have a preference for how to say SQL or SQL. I'm going to call it SQL most of the time, but that doesn't mean I haven't been saying it for 20 years because other people might say SQL all the time. So some things, the reasons that we use Postgres at HackOregon is because it's open source, but in general, like a lot of the industry trends have been to use a kind of an industrial database in the back end and then build in the business logic in the middleware and then working on the presentation in the browser, really. Did you want to talk at all, Ed? Do you have any considerations about back-end frameworks, about what's more popular or what's going up or down? It seems like Python and Django are still pretty popular.
You know, there's actually 3 of them that are popular. There's Ruby on Rails, there's Django, which is in Python, and then there's Node.js, and there's a lot of backend frameworks that work with that. None of them, to my knowledge, will scale all the way up. Once they're fine for building a simple web app or a simple site, at some point you have to, if you get big like Twitter or Facebook, you end up porting a lot of code to things that are much more efficient. Classic example is Twitter. Twitter was a Rails app, and it was a Rails app for a long time until about 2009 when people started thronging the Twitter and inundated it, and Rails just couldn't cut it. And they ported a lot of stuff to the JVM machines, Scala, Java, regular Java, a whole bunch of other stuff. They basically rewrote the whole stack from Rails into JVM software because they couldn't scale it. So we aren't that big.
One thing I was impressed
We
with.
aren't big enough to need to do.
I went to PyCon 2 years ago, and Instagram was one of the keynotes. Somebody from Instagram, and they use Python, Django, and Postgres, and they were still using it. They were upgrading from Python 2 to Python 3 or whatever. But it's surprising.
I think where this comes into the question of databases and things too, and we'll get back to this later, is there's always a question, it's always like, at what point does what you're using now work versus going to the next point there? I think, depending on the logic, sometimes we're working, like tonight, we're definitely talking a little bit more about moving to backend frameworks there. But at some point, the Django might be stored in like a view in Postgres. So we're always trying to find the balance of that a little bit there. So what technology might work for a while, if you start finding it's slowing you down, then maybe we need to talk about that again a bit more.
So the key thing is that the database, Postgres, is the persistent data layer. And especially when we're doing a lot of data science, you're going to have huge data sets. You need a robust database, and Postgres seems to fill the bill for that. So some of the features of Postgres, industrial strength CRUD. When it says fully ASCII compliant, that means that it supports transactions, which means that the integrity of your database, you can make certain things atomic so that there isn't like a partial transaction where the database will be in a half state and something will be written and before it can be read, or read before it's completely written. It scales to huge installations. It's got, it's very high availability. When we're running it on Amazon RDS, it seems to be pretty responsive. It's got full text search. You can actually add extensions to write procedures in different languages. And one nice thing that's both nice for APIs and also for loading data is that it works with JSON data types. We talked the other day about foreign data wrappers. At HackOregon, we're not going to be using the foreign data wrappers, mostly because you'd have to have that installed on the RDS instance, and you'd have to have the data somewhere accessible from that. So it's nice if you're running on your laptop, but in production, you don't expect to be able to access something like SQL or a text blob or something like that. Microsoft SQL. Let's see, I'm going to open this one up, I think. I just wanted to point out here in the slides, I kind of documented a page on GitHub of the different tools. Some of this is a little bit out of date, but it kind of describes what's Postgres and how we use it. What PostGIS is, which is the GIS extension for Postgres. PgRouting, which we're going to be talking about later in here. And then a bunch of tools for working with importing stuff into Postgres from GIS file formats. And then it also goes through some of the Dockers. We talked about containers at a training last week, and then covering something about Jupyter Notebook. So if there's anything in tools that you're wondering about, this page was supposed to try to just give you a good overview. It's in the slides. Is there a way to share the slides with everybody here? To type that URL in, I noticed you're grabbing your keyboard there. I forgot your name?
Peter.
Peter. So we're just getting started, a couple of pages in. We don't need to actually go through the installation now, unless you guys already have it installed. You can work along on some of the query stuff. But pretty much install the most recent version, 11.3. If you installed it last year, you're probably at 9 something. So you'll probably want to upgrade to 11.3. Okay. On Windows or Mac, these are from Ed's slides. This is how to install it on Linux. That's the Postgres. What's PgDG stand for?
Yeah,
Postgres?
PostGresQL Global Development Group.
Okay, development group.
They maintain repositories for just about all of the major Linux distributions. On Mac, there are 2 ways to do it on Mac. You can either use the Enterprise DB, or a lot of people use Homebrew for it and build it from source. On Windows, Enterprise, there's 2 for Windows. I don't know anybody. There's one called BigSQL, I think, and the other one's called Enterprise DB. I've always used Enterprise DB.
Yeah, this link on the screen will take you to the Enterprise DB one.
And of course, you can also do it in container.
And the RHEL is Red Hat Linux.
Red Hat
Enterprise Linux, yeah.
Amazon Linux is mostly compatible with RHEL 7, as far as I know. But they can't actually say that because without getting sued. But the repositories, the PgDG repository will work on Amazon Linux.
So here's the key thing about Postgres. We were talking about it. It's even though you can run it in a container, go ahead and just install it on your laptop. It runs on most operating systems, and it's a lot easier to work with the database on your laptop and tweak it around. And then we'll talk about kind of the flow of data. But if it's on your laptop, it's a lot easier to load something in, mess around with it, change it, work with the schema, kind of discover things, and then make it shareable later.
I would say too here, like our general deployment strategy has not been, say, deploying databases along with APIs. Direction team's going to be a bit different there in terms of, because you are doing post calls and a few things like that. But generally there, we're not going to be deploying a database along with our API. So you can develop a database backup independently of API, and then we'll put it out into the cloud, into RDS, to talk a little bit more about.
I'm also going to talk about PgAdmin, which is separate from Postgres. It's kind of a GUI admin tool for Postgres. It's available here, PgAdmin. And it runs in the browser. If I can find my browser. There it is. Very pretty. I guess I should hide some of my bookmarks or something like that. So connecting with PgAdmin and Windows, it's relatively simple. I'm going to show 2 different ways to connect. In the browser, you can just right-click and connect on the server, and it's going to ask for the password. And in Linux, you said by default it's empty. Is that right?
It depends on the distribution. There's 3 ways to authenticate with Postgres, and the simplest is called trust, which is you have a role name on Linux. A role name in the database is the same as your role name in
the OS and the database.
You can connect, but you have to set that up as a Postgres user. Depends on the distribution. Some of the distributions initialize the database when you install Postgres, and some don't.
In Windows, it prefers to use the Postgres user.
Yeah.
So you
When you install Enterprise DB, it walks you through a bunch of dialog boxes. You set up the Postgres user
and enter the password.
and you give it a password. You pick the port and you pick the locale. And I think there's a couple other things. There's also an extension stack, a stack builder or something like that. That if you want PostGIS, you have to go into that and install PostGIS.
Under this link here, I think are a bunch of screenshots of the actual installation. If you guys have any problems setting up either Postgres or PgAdmin. So
Yeah, Ubuntu and Mint is one of the ones where they initialize the database when you install it. The Red Hat family doesn't do that. I don't remember. I think Debian initializes it by default too. But the one that comes with your distribution may be old, may be 9.6 or something like that. You may, if it's PG, if you're using PG, Postgres, you'll have to initialize that yourself.
who here has already installed on Postgres?
I have it on my machine at home, but not here. I'm basically doing everything in containers. I'm doing Postgres in containers now because I get the same Postgres everywhere.
Do you guys have any questions about the install, or was there anything weird or some comments?
There was like some extra thing that they wanted to tell after it was supposed to be. Like
Oh, don't do that.
yeah, I didn't do that. It's
Wait.
stack, like something.
Is it the stack builder?
Yeah.
You want to go through that if you're going to get PostGIS, because PostGIS is part of that. But that's the only thing you need to you need from stack builder.
What is it again?
PostGIS, PostGIS. Not sure it's got like a long name in stack builder. Stack builder. Here.
Yeah, you can download those just directly too.
Yeah.
Enterprise DB also works on. There's also a Linux to. If you want to be compatible with other Enterprise DB, and it has a GUI installer too, just like on Windows or Mac.
So I was talking about CRUD a lot, and that's pretty much a create, read, update, and delete. Some nice things about SQL, if you haven't used it a lot, is all set-based. What is this? Oh, we've been updated. All right. So the set-based rather than, I mean, in 1992, that was a big advancement that all of a sudden you could deal with tons of data just by querying stuff and not telling it how to index and how to read each record and so on. Now they, with MongoDB and other things, they're like promoting kind of big blob databases, but it's still nice to use SQL for things that are fast queries that are organized. And also the cool thing about SQL is that a lot of the schema is all implemented also as data. So you can query the schema, you can query which procedures. If you understand how to get into it, you can see who are the users, what extensions are applied, and so on. Creating includes creating the database and then creating views and columns and changing tables, editing anything in the schema. I'll talk about it a little bit, but for the most part, it's what kind of the way that we're going to promote it is not really going in and changing the schema directly, but changing your models in the API. Changing your models in Django and pushing that to migration to the database. I'll get this out of there. And you guys, have you loaded data? You guys have loaded Postgres before? Okay. So I'm just going to go through this exercise of creating a table and then loading the data into it. And I'm going to use, let's see, it's this sample that's right here under the GitHub on HackOregon. And I've already actually loaded it in here. So I'm just going to start up Postgres, or actually I haven't talked about this yet. The PSQL is kind of the command line interface for Postgres. And it is installed with Postgres. And once you get in there, it's pretty much the same on Unix or Windows or anything. Oops, fatal. You know why? Because I didn't tell it which user. Oops, I didn't type it right. There I am. So now I'm in the Postgres command line. Can you guys see that? Okay, or do I need to make it bigger? Resize something. Let's see, from that. So I'm just going to create this database right here, the command line, and it goes out. It's creating the database, and will show up in my local database PgAdmin once it's done. So it's done creating the database. I'm just going to refresh this guy.
Can you go back? What was the command you used to create the database?
Yeah. So I used the command pretty much create database, and then I gave it a name, Krusty. And the only special commands I actually gave to it were I told it who the owner is, which is default Postgres. Encoding is UTF-8. And I don't remember exactly what the connection limit command parameter is, except for it just here it's just saying there are no connection limits. You could make it 1 or you know, a number that would actually be limited if you wanted.
That's what, like the number of people or users
connect at a single time. Yeah.
Thanks.
So did you already have a user in Postgres set up?
Yeah, when you do the installation, that's what Ed was talking about. On Windows, it wants you to set up Postgres. And actually, that's one thing that's interesting about Postgres is it maintains, let me show you this right here. So it creates a Postgres maintenance database. When I create this database here, there's the maintenance one that's underneath that. And that's what actually, at the higher level, it keeps all the login, the access, the roles, basically. So once you've created the main database, then it uses those users over again. Unless, like at what we've done in HackOregon, they're actually separate instances of databases, right?
Yeah, each team will have its own database instance, which you then create a database in.
This guy I did not create with, he doesn't have the PostGIS extension. But if I wanted to add the PostGIS extension, let's see. I don't remember what it is. That's embarrassing. I haven't written it down yet. Is it install PostGIS? I'll ask it. And to install PostGIS, is it just create extension PostGIS? Is that what it is? Create extension PostGIS. Is it no such file? Well, I won't go into this right now, unless it's case sensitive. I won't get into that right now. I'll have to look that up. So I'm going to continue with the loading part that I was talking about. To make sure that I can load the table, I'm just going to drop it if it exists. So I'm going to just paste that in there. In this case, I know because I just created that database that the table's not there. But this is a nice way just to make sure that everything's cleared out before you start to add into it. I'll share the commands that are in here so you don't have to worry about taking that.
We're also, we are recording the video and the audio tonight, so it'll be up on things too to go back and.
Like when you're loading your database in, if you're relying on some SQL commands to create things, you want to make sure that it is reset for you're creating the new table. So it's a good thing just to add.
Take from PostGIS, just install PostGIS from the app. Correct? Is that correct?
I don't remember if I did that on this computer, but it's in the database.
It's like a separate from Linux. With Enterprise, everyone the stack builder. I don't know.
So before you do the you would
Has a pre-installed Linux or an Enterprise DB has to be installed.
It may be that I don't have PostGIS installed on this computer. I'm sure.
Well, that's
Yeah.
Yeah. Look your start menu, go stack. Probably stack. You stack what's all folders now. It's not. I'll do that for you. Yeah. You do that.
So here's there was a little this is trying to create a table. This I know this schema of the table that I'm going to be loading, and so I just put in here are all the fields that's going to be loading, and I just create them all as text. In this case, I don't really care because I load it as text. I don't care if it's integer or only a 10-character string or something like that. If you wanted to be more accurate or if you wanted to have higher performance, it's good to define the fields exactly. Like if you define it as an integer, then it's going to not take up as much space and it's going to be faster to index than if you define everything as text. But in this case, I'm just going to load it in. The only thing that's very exciting here is long and lat are double precision numeric. So I'm going to create this table. And notice that the semicolon is really the thing that triggers that there's the command is complete. And then over here, if I refresh this, under schemas, public, tables, I created on the right one. I probably didn't connect to the right database. Yeah, and that's going to be under this guy, isn't it? Yeah, so I created it under the Postgres database. If I wanted to change to Crusty,
I think it's /C.
C, Crusty?
Yeah. Yeah.
Now I'm connected to Krusty, and so that I can actually rerun that.
I think we do. Oh, there you
Now it'll be under the right database.
have to refresh it. Right click. Yeah, there you go.
There it is. There are the columns.
So you just created a table inside of the Krusty table?
Krusty database. So here's the Krusty database. So the interesting thing, I mean, the thing about Postgres is it'll make this maintenance database, the Postgres one. And when I logged on, I just automatically logged on as the Postgres user, and it put me connected to the Postgres database. So if you're running from PSQL command line, you'll want to remember to change the right database. If you're running from PgAdmin or something like that, you know, it's a little bit more visual. You're like, oh yeah, I want to do this database for this one. Or if I create a new database, I can just say create a database, and I can call it shmoo. Oops. It takes about the same amount of time. Now I'm in shmoo, and if I wanted to create it, go in here and under the schema, let's see, create a table. I could create it here graphically, or I could run the SQL and create it that way. So I'm going to not use shmoo. I'm going to get rid of that. Go back to Krusty. So I've got the database, I got the table. I need to load some data into it, and we use the copy command. And just show you. I'm going to just show you for anything I would go into. This data is CSV. Pretty. So I'm going to go into that and just copy into there. So it loaded into the table milepost 2014 file, which is my directory CSV. And I said with CSV header, so that's how to load it. And now if I here, go down to the table. I can query this. There's the data loaded in. And you know, you can see that column definitions are all text, except for these guys are double precision. Was there anything you guys have any questions about that, or no, nothing right now? Okay.
School watch created.
What's that?
School watch created.
So this tip is, you know, you don't know the data type, do it as text, but it's actually more efficient if you can figure out what it is advanced. Or, you know, as you can see, it loads quickly. So, you know, script it and load it a bunch of times and see which way it works best.
There are utilities that will guess CSV file. In theory, you have to read the whole file. There's a column be like 98% integers, something like that. And there are utilities that guess. What was the Python package? CSV kit. CSV kit. Yes.
Go on.
So during the pizza break, I installed PostGIS, the correct version, and then I ran create extension PostGIS, and it actually was happy. And if I go back into here and refresh, now you can see that the PostGIS extension is installed here in the crusty database. And this is kind of what I mean by everything's data. You can go and see all these things. That's pretty, you know, it's pretty much all just, oh, this one's probably not going to show me anything. But at least it shows it as data in the GUI right there. All right, so let's get back to the presentation. Let me find the right screen. One thing earlier I started to type in something and I used a uppercase to start it with, and then I realized don't do that. If you can, name everything with snake case with lowercase and underscores. Otherwise, you have to double quote your field names or your objects. Postgres is kind of picky about that. So it's a lot easier if you can use your fields as lowercase and underscores. So we went through the PSQL copy.
Why is that?
Why is it that it's double quoted? I don't know. It's a philosophy thing, maybe. You know, Ed?
Historical reasons, I guess. They needed the characters for something else.
Some namespace or something.
Yeah. It wasn't SQL itself is case sensitive. You can like select all uppercase or all lowercase, and I think it's like an early parser somewhere had that restriction.
Or like the hyphen is probably seen as a like a
There's a
minus
minus
sign
sign,
or
yeah.
something like that.
R is kind of rude about that.
Yeah, I know. I was trying to just create our transportation systems main database, which is all hyphens, through the RDS, like RDS, like Amazon console, and it gets rejected.
The funny thing is all the client libraries will just treat it as a string, and if you send it to the database as a string, it knows it's looking for a string, and it'll be perfectly happy doing it.
But if you type something in and it's not double quoted and you query it, all of a sudden then it says field not found. Remember this thing and put in some double quotes. So here's an interesting thing. In PSQL, you can mix commands. So let's see. I have a cheat sheet somewhere for SQL. I won't go to the cheat sheet. We'll talk about that in a little bit. But the nice thing about PSQL is you can script it. So once you figure out what you're doing, you can just pretty much load things into a script and then call it from there, run the commands. And then if you have a script also, you can put it in GitHub so you know when things are changed and what the differences are. But as Ed points out, it's a different language. So if you prefer to work in something like Python or R, you could do it that way instead. I just went through and listed here some basic, these are kind of the more common data types that you might find in Postgres. You know, car is a certain fixed length that's it's padded state with characters at the end, versus varchar, which is a variable length. And so if you want to be more efficient, you can use varchar, but if you know something that's going to be a small fixed length, just use a car 10. And text is kind of a variable length blob. Integer, don't define an integer type that's, if you're thinking it's going to be bigger than this number, you can use a large int. I don't know, timestamp is a useful one. There's actually a JSON type in the database, so that's handy. And then if you add the PostGIS extensions, there are some PostGIS, there are some geospatial extensions, their types. Let's see, so I'm gonna go fast if you guys know everything. There's the select. You guys, have you all done a select statement? In the slides, these actually go to like the Postgres page, documentation on select with all the other features. Let me get back to that. But basically the key thing is, you know, the nice thing about a select, you can add some filters with the where, and you can also join it with another table if you need to join data, and you can set the order by on the back end. For an example, in here for the mileposts, I think I just put these guys in here. We can just run through in here. We have the query tool. Paste the query in there and run it. There are the results. And I could, if I wanted to do the order in a different order, those are kind of hard to see. Data output. If I wanted to order it by, let's say, for some reason, the milepost, I could just do order by milepost. Oops. Order by. And now it's milepost. It's good if you're playing around with your data, like if you're not sure, like you're saying, you're parsing something, you're wondering, why isn't this loading? You can just go and check out different fields and say, you know, I was expecting this to be a positive number. All my mileposts should be positive. Why is this one a -6? You know, there's something weird going on. For the most part, you know, your front end logic or your middle logic is going to, your middle tier is going to probably set what order things are going to be served up. But you can also stick this into a view or into a procedure and hard code what order it shows up. Let's see.
With the middleware too, like ultimately it's always trying to run a select statement or a SQL statement in the background. Like, you know, so all that stuff connects to the SQL. So the more you know about what this is doing, when you're like, why is this taking 3 minutes or something to run? You can be able to see the SQL statement. You're like, oh, because it's pulling all the fields for 1 million rows or something like that. Maybe I just need 3 rows, you know, so you can understand, hey, what this select statement is doing, how it's ordering, like how does that make sense to my logic. So it's definitely always good to, even if you're just building, say, the API and not building on the SQL statements, so we understand that background of what it's selecting and what each of those processes are doing
now. Alter table to change the definition of a table. And so I'm going just through basically the CRUD parts. So the create part, we were talking about that. To read was the query statement. Updating, you know, updating is updating data, but also think about it as updating the schema. So some keywords to think about are alter and table and update. Some examples right here. You might want to alter the table, like after you've loaded this data in, but before you actually put it into your production database, maybe you want to add some sort of column that says, you know, here's the provenance, you know, here's where we got the data from. Let me find that. So let's see if I want to do a alter here. I can just put this in, execute it, and it's changed the format of the table now. I'm going to refresh it. And here's the source file and another command. So I'm going to populate it by just updating. I'm going to tell it, oh, it came from the this my milepost file. So I mean, this is not really a totally real world situation, but it might be if you guys wanted to actually keep track of which files things were coming from. Once you load the data in, then you might have a script to say, this came from that file, this came from a different version of the file. I don't know if you're, the data science people that you're working with are going to request things like that. So now I'll just query it again. Oops, sorry. And so the nice thing about this is I can just go back here and then copy this guy in and just query it again. And the output, this doesn't fit on the screen very well. Close out. Better run it. Oh, whoops. I'm just going to, one thing here, my original query defined all the fields. I'm just going to do select everything. And now I can look at it. And so there's the provenance of that file. But it turns out that I don't care about that. So I'm just going to delete that one. And so that brings me back to deleting or dropping tables or truncate. Truncate's a fast way to get rid of all the data in your tables. You know, drop table completely removes the table and deletes a set of rows. So I'll go through these examples. I'm just going to delete, I'm going to get rid of Clackamas here. Oops, wrong guy. And you guys are supposed to say, no, not Clackamas.
I love Clackamas.
Oh, I didn't have that query in there. I'll just type it in. Where is it? How do you, one thing I don't know how is once I get this thing up here, how do I dock it back in? So I'm just going to delete from public mileposts where highway name equals Clackamas. In this case, I think it's some case-sensitive database. It deleted 48 items. And then I'll just select them all back again. If I select this, it should have nothing. There it is. And if I select it, the double hyphen is the comment if you want to work with this stuff. So now if I comment out Clackamas, then it shows me everything. Let's see. And then I could also just drop that column if I wanted to. Oops. Did you guys have any questions about that schema stuff? You've worked with that. Some nice things. The only reason I'm going to mention some aggregates is because after I said everything about putting stuff in the middle tier or in the front end, sometimes it's easier to aggregate data in the back end. If you're going to get the average or the count of a bunch of records, it's easier to do it in the database than to pull over 10,000 or 100,000 records and then count them all in the front end or the middle tier. So if you're using views, you can stick some of these aggregates into the views and then keep the logic there in the back end, and it's still something that you can deal with in the schema with the, like the Django model will actually work with the view as well as a table. So this example here, select count of the public mileposts where, all the mileposts in Kings Valley, you wouldn't have to pull that all over and process it on the front end. You could just have that in your view and it would automatically tell you that way. These are pretty much the main aggregates. These are the standard ones. I don't know if there's some special ones for Postgres. Do you know?
Well,
Beyond any aggregate functions beyond these?
There are some, there's a complete listing of the aggregate functions. Oh, let me
There's some like number that just serves up a number for each row.
let me dig up the main Postgres documentation page. Because there's, that's very clear about what is, it's very clear about what's exclusive to Postgres and what's SQL standard.
It's 9.5, but yeah, you get the idea.
Documentation. There it is. Let me go to 11.
Do you find a better one?
Yeah, it's PostgresQL, postgresql.org/docs/current.
Oh, so there's a supported versions there too, current.
Current.
And one of the nice things about Postgres is with Google, they've done their SEO right. If you have a Postgres question, you type it into Google, it'll usually go here. And if it doesn't go there, it'll go to something that's a PostgresQL tutorial, which is another site, another good site for beginners. Let me dig up that one.
We are, how far are we? We have like half an hour? Or we have an hour?
I mean, half hour to hours probably.
Okay.
Yeah.
Yes, PostgresQLtutorial.com.
And so then also I'll just keep going from there. Talking about views, you can use the views to, if you have a certain join that you like to reuse, or you want to make it something that's exposed as an API. The views are a good way to put that into the backend and then use that logic to push it forward to the API.
How is a view different from a table?
Now that's a good question. Let's see if I can show you. I don't know if I can show you very well with this, but let's say that we had a view here. Actually, let me see if I can connect to the HackOregon database in our disaster tape. One thing that's nice is, like in here, we had a bunch of different things that exist in the city: hospitals, fire hydrants, neighborhood units, churches and hospitals, schools, and so on. And these are all different data sets from different areas. And rather than put them into one table and then have to deal with the types being separately, what I did was I created a view here that, let's see if it shows up. Raster overviews, geography columns. I don't know if these are in here. I expected it to be in here.
Or is it a materialized view instead of?
Yeah, maybe it is a materialized view. Nope, it's not there. Okay, so it's not in the production database right now. But instead, what I did was I created a view that would join those all as unions. And so I could query one view and have one API, but it'd be referring to 6 different tables. That's not a very good example, though. I'll have to work on my example here. Get out of there. How come I can't get rid of crusty. Yeah, not very useful. Okay, I'll avoid that. I don't think it was this database. I think it was just a different name for it.
But then the views is basically a SQL query saved into your database.
Yeah. I mean, a simple view that I guess we could do is, let's try this. Why is this guy? I don't understand this. Can you tell me how to close this?
Control W.
Might close everything.
It's pretty
Oh, yeah,
weird.
because
It's not.
I'm just going to close it.
Oh yeah, there you go.
Don't save. There we go. Dashboard properties. Okay. So we're back here. Crusty schema. If we have this table, so we have this table. Actually, I'm just going to do this. Scripts, select. Well, maybe I shouldn't spend all my time doing this. Going off script. I'll come up with a better example of that.
Yeah, no worries.
The nice thing about views is if like you find yourself having to like rewrite this like the same query over and over again to like get the data a certain way, if you make a view, then it's like modular code where it just saves
Yeah.
a bunch.
Yeah.
I'm trying to find all this stuff. There he is. Execute. There's the data. I'm not sure how to dock this back into here.
Doc, yeah.
That's weird.